show that the other forms of the Hermite polynomials are number 1, hn of x is given by 2 power n times exponential of minus 1 by 4 d square by dx square operating on x power n. And the rotates formula for hn of x is given by hn of x equal to minus 1 power n into e power x square, nth derivative with respect to x operating on e power minus x square. Now everybody knows that derivative of e power 2tx equal to what? We are differentiating with respect to x. So 2t is a constant. So 2t times e power 2tx, call that as equation number 1. Bring 2 down, 1 by 2 times d by dx of e power 2tx equal to t times e power 2tx. Once again take derivative of this. Derivative of 1 by 2 of d by dx of e power 2tx, that is equal to e by dx of t times e power 2tx. Now I am writing it. So d by dx of same thing I have repeated here. And then this becomes, when you consider the derivative once again, this t is independent of x. So t comes out. Derivative of e power 2tx, that is nothing but once again 2t times e power 2t. Okay. So 2 into t into t. So 2t square e power 2t. So finally again I am bringing 2 down. 1 by 2 derivative of 1 by 2 times of derivative of e power 2tx with respect to x equal to t square times e power 2tx. 1 by 2 d by dx into 1 by 2 d by dx. So we can write that as 1 by 2 d by dx whole square. Operating on e power 2tx becomes t square times e power 2tx. We can generalize this and then we can write this as 1 by 2 d by dx whole power n instead of 2. If I take n e power 2tx, this becomes t power n e power 2tx. Okay, generalized form. So d square by dx square e power 2tx. From there we are taking this right hand side, we are considering this. So in this is nothing but 1 by n factorial minus 1 by 4 d square by dx square whole power n into e power 2tx by 2. So this is nothing but summation n running from 0 to infinity. What is the exponential of? Just now I told e power x. What is e power x? Summation x power n by n factorial. What is e power y? Summation y power n by n factorial. Similarly, what is the exponential of this function? This variable whole power n by n factorial. What is e power z? Summation z power n by n factorial. What is the derivative exponential of this variable? This variable whole power n by n factorial taking summation e power 2tx as it is. So summation minus 1 power n by n factorial. This I can write this as 1 by 2 d by dx whole square. Already power n is there, so that becomes 2 power 2n e power 2tx. But just now we have proved 1 by 2 d by dx of e power 2tx, that becomes what? E power n. If we are having n, this becomes n e power 2tx. So this entire term becomes e power 2n into e power 2x by second one. E power 2tx is independent of n. I am bringing it outside. This becomes minus 1 power n by n factorial into e power 2n. So even this also I am going to take it inside. Minus t square whole power n I will write. So automatically this becomes minus 1 power n t power 2n. So I can write it. So what is happening once again? I am getting an infinite series. I am getting an infinite series variable power n by n factorial. So this term becomes what? E power minus t square. This what it becomes. This infinite series becomes what? E power minus t square. That is why e power 2tx into e power minus t square. This is nothing but e power minus t square plus 2tx. So this becomes exponential of minus 1 by 4 d square by dx square times this e power 2tx. What is e power 2tx? Once again I am asking. E power z. What is e power z? Summation z power n by n factorial. So what is e power 2tx? Summation 2tx whole power n by n factorial. That is equal to, once again here, this is a generating function. Just now we have seen in the previous problem, t power n by n factor into hn of x. So on both sides, we are going to compare t power n coefficients. What is t power n coefficient here? Exponential minus 1 by 4 d square by dx square. T power n coefficient 1 by n factor into 2 power n into x power n. What is t power n coefficient on the right hand side? hn of x by n factor. N factorial, n factor we can cancel both sides. Therefore hn of x becomes this value. Okay, 2 power n into this function into x power n. So another form of hn of x is given by, in terms of exponential functions also we can calculate. Previously we have given as a series. Here we are giving it the exponential form, 2 power n into exponential minus 1 by 4 times second derivative with respect to x times operating on x power n. I hope that is clear.